Alright, today Academic Daddy will be taking you on chemistry class, and today is going to be a revision class. So the question before us says find the mass percentage of iron trioxide, ferric oxide. Atomic weight of iron is 55.8, then oxygen is 16.0. So remember, mass percentage is equals to mass of elements. So the element they're asking us to find the mass percentage is iron, all over total mass, or you see molar mass. And you know that when we talk about molar mass or molecular mass, we are referring to the whole compound. So this means that this will be iron there, that is molar mass of elements. So molar mass of the element here, or atomic mass of the element as it is there, Fe is in two places. So it's going to be Fe2, which is the same as 55.8 times 2 all over 55 2 plus, that's 55.8 times 2 plus 16 times 3. This is going to give me, if you punch it, it's going to give me 55.8 times, so we have 159.6. So when you do this punching, we have 111.6 divided by 159.6. So we have 0.6992, so which is approximately 0.7. So let's check. So you see that we have this, and that is the same thing as what we call mass fraction. So we've gotten the mass fraction, and we know that mass percentage is the same thing as mass fraction times 100. So it's the same thing as this. So since we've gotten everything here, the elements divided by the total mass, we've gotten the mass fraction. Now times it by 100 so that we do everything here. Okay, remember I told you not to approximate until your final answer. So when you punch this, you now have that times 100 is going to give you 69.9%, which is approximately, if you do this times 100, approximately 17%. So that is for question 1. So let's move to question 2. Question 2 is asking what is the molar mass of strontium chloride dot 6 molecules of water. So I have SrCl2.6H2O. They're asking us for molar mass. I need you to know that when is molar mass, it's talking about taking note of the lineup of the compound. So given to us, strontium is 87.6. So I told you molar mass or molecular mass is, or molecular formula, molecular mass, whichever one, is simply the individual sum of all the elements, the atomic masses of the elements in a compound. So plus Cl is 35.5. Now notice there is 2 there. Dot 6. H is 1.012 plus 16. Notice that the 16, because this compound is affected by this 6, it will affect this oxygen. So 6, 16. Atomic mass of oxygen is 16.0, which is the same as 16. So when you sum this up, you will get, so when you punch this, you will get 266.72. So 266.72. And you know that the unit of the set include the correct unit. The unit of molar mass is gram per mole. So that is it for question 2. Let's move to question 3. Question 3 says, how many moles of oxygen are required to react with 12.0 grams of carbon? So this is gram to mole conversion. So how many moles? So oxygen required to react with carbon. So oxygen, O2. Oxygen exists as diatomic plus carbon to produce carbon monoxide, which is CO. Notice that oxygen is 2 here. Here is 1. Add 2 here. If you add 2 here, it affects this whole compound. Add 2 here, so that this becomes the balanced equation. Now, once you've balanced this equation, you need to check something. Always start with this. There is no stoichiometric coefficient before oxygen, so it's in the ratio of 1:2. Now, whenever you're doing stoichiometry and you have just one equation, the equation given to you is one equation, focus on the given value and what you are asked to find. In this question, they said how many moles of oxygen. So watch, look at what I'm going to do. Moles of oxygen. Oxygen is what we are asked to find. We are finding oxygen. Now, are required to react with 12.0 grams of carbon to produce carbon monoxide. It produced carbon monoxide, but notice that they did not give us any value for carbon monoxide, and they did not tell us to find anything about carbon monoxide. So always focus on what you are given and what you are asked to find. So here I will write on top of it 12.0 gram is given. So my business is with oxygen and carbon. Just know that. So for that reason, it's in the ratio of 1:2. Now, if it's in the ratio of 1:2, I need to find the mole of oxygen, but I don't know the mole given to me here. So for me to find the mole, I'll simply say mole of carbon first of all. Mole of carbon is going to be equals to, mole is mass over molar mass. So I will now say mole of carbon, which I don't know, is equals to the given mass, which is 12, and the molar mass of carbon is the atomic mass, which is 12. 12 divided by 12, so gram all over gram per mole. So 12 divided by 12, gram divided by gram, I'm left with mole. So this is 1. So I will have N equals to 1 mole. 1 mole. So when I come here, I will get it that solving, I now have 1 mole to produce 2 carbon monoxide. So 1 mole of this will react with X mole of oxygen. So when I cross multiply, 2x will be this side. 1 times 1, 1. So x will be equals to 1/2, which is the same as 0.5. So 0.5 mole. So the mole of oxygen is 0.5 mole. Even sometimes this thing is very easy. Once you've gotten the mole of the given, the one they gave you, once you've gotten the mole, please go and watch our video on stoichiometry. Once you've gotten the mole, then the easiest way to find this is to check the ratio. You can see that this is 1:2, and you are getting the mole of carbon to be 1. That means if it's 1:2, half of 2 is 1. So if I'm getting the mole to be 1, I will say half of 1 is not 0.5. So that's the answer. 0.5 moles. Let's move to question 4. Number 4. How many moles of Na, that is sodium hydroxide, how many moles of sodium hydroxide are required to react with SO2? So that is sulfur dioxide, or you say sulfur 4 oxide. So to react with SO2 produced by the oxidation of 0.500 moles of Fe2S. The balanced equations are, now notice something. They are asking you, let me write this out. 4 ion O2. Now watch. And notice something. Notice that the part where I have iron sulfide, where I have this iron and S2, there is no NOH here. Now on the second part, I have SO2 against reacting with NaOH. Then I have Na2SO3 plus H2O. Now notice, if that is the case, I'll ask myself, what ratio is this to? Notice that they mentioned how many moles of this required to react with this. But at the end of the day, what they gave me is 0.50 moles of iron sulfide. Now notice that if that is the case, it means that I will come to my equation. Stoichiometry is defined as the relationship between reactants and products in a chemical reaction. So these are my reactants, these are my products in this equation. Now notice this part. So since this one oxidized and they are asking me how many moles of this and this will react, it's simple for me to now check the ratio. The ratio I have here, stoichiometric ratio of this is 1:2. Are you understanding it? So if I have this ratio of 1:2, it simply means that if they are asking me how many moles of so that means if they're asking me how many moles of this will react with this, all I need to do now in this case is, since I know that this has been produced, to check the balancing of this equation. If it's balanced, that means that 2 NOH, 2 moles of this will do the job. So let's move to number 5. They say a compound of sulfur and fluorine contains, so sulfur and fluorine contains 29.7% sulfur and 70.3% fluorine. Percentages are by mass. Number 5, percentages are by mass. What is the empirical formula of the compound? Let me tell you, even if they did not tell you percentages are by mass, once you see this kind of question, just know that that percentage given to you is the same thing as the mass. So I will do 29.7 gram, 70.3 gram. I'll ask myself, what is the gram of sulfur and what is the gram, that is the atomic mass in the periodic table? What is the atomic mass of sulfur and what is the atomic mass of fluorine? So atomic mass of sulfur is around 32 gram per mole, thereabouts, 32 gram. So and that of fluorine should be around 18 gram, so thereabouts. So if I do 29.7 divided by 32, I get 0.928. Now if I do 70.3 divided by 18, I get 3.9056. So which one is the smallest here? So once you've gotten this, first is to divide by the atomic mass, the first step. Second step is to divide by the smallest number, the smallest value from your answer. So I will now do 0.928 because it's smaller. I'll divide by 0.928, then divide this 3.9056 by 0. Please try to punch your own to see if we are correct. Calculators these days, So when I divide this, it's going to give me 1. Now when I do 3.9056 divided by 0.928, I get 4.208, which is approximately 4. This is 1. So if you want to check this now, the empirical formula, so first divide by the atomic mass. First divide by the atomic mass. Second, divide by the smallest value. So once you divide by the smallest value, the ratio you have is now, this is now a ratio, because if you notice, the gram and the gram has left. So you divide this so that you get a ratio that will give you 1. Now once you get this, now this is now empirical formula will now be such a way that this is S1 and F4. When you put it together, this is SF4. So this is your answer. So number 6 question. Please, if you don't know how to balance chemical equation, go and check our video on stoichiometric equations. Now they say, how many grams